For decades, raw rubber was a frustrating material. In summer heat, it melted into sticky paste. In winter, it became a brittle solid that shattered upon impact. This limitation was overcome in 1839 when Charles Goodyear perfected vulcanization, a chemical process that used sulfur to cross-link polymer chains, creating a material that remained durable and elastic across all temperatures. This chemical breakthrough turned an obscure rainforest resin into a critical strategic commodity. As factories electrified and moving assembly lines began producing cars, every vehicle required dozens of pounds of vulcanized rubber for its tires, hoses, valves, and wiring. Because the only source for high-quality commercial latex was the Hevea brasiliensis tree, this surge in industrial demand created a highly leveraged geographic monopoly in the Amazon basin. Between 1850 and 1910, this monopoly generated staggering wealth. Remote jungle outposts were transformed into opulent cities like Manaus, where rubber barons funded grand projects like the Teatro Amazonas, using materials imported piece by piece from Europe. But this wealth was restricted by a biological barrier. The Amazon is the native home of South American leaf blight, an aggressive fungus that attacks and kills rubber trees when they are planted in high-density groups. In the rainforest, Hevea trees grow in a highly dispersed pattern. This distance acts as a natural quarantine, preventing fungal spores from easily traveling between hosts. But this biological defense made wild harvesting exceptionally inefficient, forcing tappers to walk winding trails covering dozens of miles. This logistical nightmare required a massive workforce, leading to the aviamento system. Landowners advanced travel costs and supplies to workers, trapping them in insurmountable debt and forcing them to harvest wild rubber to survive. Measured, summarizing Brazil's monopoly was structurally fragile because its entire labor and extraction model was dictated by the behavior of a single endemic pathogen. Determined to secure a cheaper and more reliable supply, the British Empire commissioned explorer Henry Wickham to collect 70,000 seeds from the Amazon. This record clarifies Wickham did not violate a legal ban. Brazil had no laws forbidding seed export in 1876. He exploited customs protocols, declaring the cargo academic specimens for Kew Gardens, avoiding delays that would have rotted the oily seeds. Upon arrival, botanists at Kew worked with extreme urgency. They planted the seeds in specialized hothouses the day after delivery. Out of 70,000, only a fraction successfully germinated in the British climate. This map traces the subsequent journey of those seedlings. Nurtured in glass terrariums, they were dispatched to British colonies in Southeast Asia, including Ceylon, Singapore, and Malaya. This transfer functioned as a calculated geopolitical maneuver to bypass the biological bottleneck of the Amazon rainforest. Southeast Asia possessed a perfect tropical climate, but completely lacked the microcyclus ule fungus. Freed from the threat of blight, colonial planters could pack thousands of trees together in high-density monocultures. This geographic advantage increased the latex yield per acre and eliminated the need for workers to search through the wild jungle. Botanist Henry Nicholas Ridley optimized production with the herringbone tapping method. Precise incisions allowed for daily tapping of the same tree for decades without causing structural harm, turning a wild resource into a predictable agricultural yield. The British paired this scientific efficiency with a vast pool of cheap indentured labor. By 1913, the low cost of plantation rubber began decisively outpricing the expensive wild rubber of the Amazon. Global market dominance shifted when capital found a path of lesser biological resistance. The high overhead of the Amazonian collection model could not compete with the sheer output of the Asian plantations. In the late 1920s, Henry Ford attempted to break the British monopoly by building his own massive plantations in the Brazilian Amazon. His fatal error was attempting to force dense monoculture planting directly into the native territory of the leaf blight. The ecosystem fought back. By planting trees close together, Ford created the perfect environment for fungal spores to cascade rapidly. The blight ravaged the crop, halting latex production. After investing millions, Ford sold the devastated land back to Brazil in 1945. The total ruin of Fordlandia remains a lesson in the high cost of ignoring local ecology in the pursuit of agricultural efficiency. Ford's failure confirmed that even massive industrial capital cannot overrule the fundamental biological rules of an environment. During World War II, the occupation of Asian rubber supplies by Japan forced the Allied powers to rapidly develop synthetic alternatives derived from petrochemicals. While synthetics now account for 60% of global consumption, these laboratory variants have a specific performance ceiling. Modern chemistry cannot replicate the perfect molecular geometry created by the living rubber tree. Enzymes inside the tree ensure that every link in the polyisoprene chain follows a naturally ordered, symmetrical structure. This biological precision gives natural rubber unparalleled tear resistance and the ability to dissipate internal heat under immense physical stress. Because of these properties, natural rubber is still strictly mandatory for high-stress applications, such as the aircraft tires that must bear the weight and friction of a commercial jet during landing. Despite our advanced technology, the modern industrial world remains fundamentally tethered to the biological output of a rainforest plant. In 2026, global demand continues to exceed production, a deficit now complicated by new regulations like the EU Deforestation Regulation. Proving that rubber is deforestation-free across a fragmented supply chain of 6 million smallholder farmers is a massive logistical challenge, requiring unprecedented geolocation data and transparency. The journey of a few seeds in 1876 provided the physical material required for the automotive revolution and the expansion of the global electrical grid. History is shaped by the physical constraints of biology. While industrial power can build empires, those empires remain subservient to the ecology of the Earth.